This video is how I made the individual throttle body fuel injection system for my LS1, LS2 motor. It's basically a poor man's intake. The next three photos shows the LS Pro-Flo XT intake from top, side, and in view. It's basically a tunnel ram for fuel injection. It has 8 individual runners that are aligned with each other, same length, spaced along the bore spacing, and make an ideal setup for an ITB with just very few modifications needing to be made. The in view shows how the configuration of the runners comes up and meets at the common plenum. This was an issue that had to be resolved later by making them more upright rather than canted toward the center plenum. To do this, to make them more upright, the first thing I had to do was split the intake manifold down the center using a table saw. Notice that I left the plenum halves intact at the top of each of the runners. This was to keep a rigid connection of all the intake runners at the top so that the runners could not get misaligned during further machining steps. Once the manifold was split, I cut wedges out of the bottom of each of the individual runners, and then I broke the manifold over on top of those wedges to reconnect it and then re-weld it where the two halves came together. And this makes it very obvious here where you can see where the need for keeping the upper plenum intact with the upper runners so that everything stayed aligned while I was doing this welding process. This photo shows the before and after of that welding process of making the runners more upright. The top portion of the photo shows the unstraightened runner, and then the bottom one shows where it's been canted over. Now you'll notice there's about 1.5 inches of offset between the two, so in essence it created about 3 inches of gap or separation between the two individual banks. This photo shows the intake runners with the complete removal of the top or the remaining portion of the plenum. In the foreground you see the adapter plate made out of 3/8 inch aluminum that will fit over each of the individual runners and then be welded in place so that now I have a mounting plate attached rigidly to each of the individual runners. The issue that came up after welding this plate in place was that it shrunk, causing a convex head mounting surface. To alleviate that problem, I had to separate each of the individual runners or slot the mounting plate between runners so that I could allow the mounting plate surface to relax and straighten back out. Once I did this, I took it back to the machine shop and had them put it on their milling machine and ensure a good flat surface for the mounting plates. This section deals with the modifications of the Chrysler LHS 3.5 liter throttle bodies. These throttle bodies are made by Hallett. They're 48 millimeters in diameter, and this photo shows as they arrived from the salvage yard. About 75% of these throttle bodies will need to be the left-hand side, as identified by the throttle cable being attached to them. This is because the throttle shaft themselves lends better to this modification than do the right side ones, but you will have to have a couple of right side ones for the throttle position sensor or the TPS sensor that has the blade on the end of the shaft that is used to operate that sensor. The next photo shows a schematic of the cross section of the throttle bodies. Notice that it is 48 millimeters at the blade, but it necks down to 42 millimeters just above the blade and then tapers out to 62 millimeters at the top. Now this 42 millimeter restriction can be easily taken out with a die grinder with care not to get into the walls where the throttle plate makes contact. The next photo shows the individual throttle bodies mounted on the adapter plate, which is 3/4 inch thick aluminum. A single throttle shaft is placed through each of the throttle bodies to keep them aligned, as I used the throttle bodies themselves as templates for drilling mounting holes. These mounting holes were tapped, and then the OEM Chrysler studs were installed. They had special shoulders on them to help index and align the throttle bodies. And then these throttle bodies were remounted back onto the adapter plate so that I could ensure a good fit. And then this was done for both left and right sides. The next photo shows the throttle plates and throttle shaft. The right side piece is the throttle shaft as it came from the manufacturer. It has a slot in the center of it for the throttle plate. What I did was removed half of that throttle shaft so that I could allow more air into the motor at wide open throttle, and then reinstalled the throttle plate onto only half the shaft instead of through the middle of the whole shaft. And this opened up quite a bit because that portion that I removed was about 4 millimeters thick and almost 50 millimeters long. The next photo shows the mounting of the adapter plates onto the individual banks of the modified intake manifold. You'll notice the left side has the adapter plate completed with the transition or the adaptation of the round hole into a semi-rectangular Pro-Flo intake manifold port configuration. This photo shows the left side with the throttle bodies attached and the modifications made to the throttle plates and the throttle shafts, and the right side completed but without the throttle bodies and only the gaskets placed on top of them. The next photo shows the entire assembly mocked up with all throttle bodies installed on top of the adapter plates, which adapts the round hole to the semi-rectangular intake runner configuration. Now as we go on to the photo of the end view, you'll notice that it shows the more vertically oriented runners that were made by cutting out the wedges in the intake manifold and then straightening them back up as seen by the welding bead along each of the bottom of each of the runners. I now have about a 3-inch gap between the individual banks, which will allow the locating of the throttle actuating system, which will now fit in between those two banks and allow the throttle to be operated. And this last photo shows kind of a side shot of the a completed assembly, again with the common shaft in there. I have not yet created the individual throttle shafts and how they connect, but that will be shown later. This last section has to deal with mounting the throttle actuator to the valley cover. The throttle actuator was one that I fabricated for a Weber setup, which was basically a 1/2-inch thick aluminum wheel that was mounted onto the tower using 3/4-inch ball bearings top and bottom to sandwich around the wheel. The tower itself is a hollow 1.5-inch diameter tube which is sealed on both ends and then bolted onto the valley cover. This tube acts as a vacuum reservoir or chamber in which all 8 throttle body vacuum ports are attached to it, and then the map sensor comes off of this reservoir. To mount this onto the valley cover, I had to weld aluminum material to the bottom, right where each of the 3 bolts went through the plate, to increase the thickness of the plate in that immediate area of the threads from 1/8 inch to about 1/2 inch to ensure that I wouldn't strip out the aluminum plate threads. And then once this is mounted in place, it fits nicely in between the throttle banks that were separated by the wedging of the runners. So it all fits up pretty well. It is operated by a cable mechanism that runs down the middle of the car, and subsequent video, if I create it, will show more details on that portion of it.